Good morning. Am I audible?
Yes, sir.
Yes, sir.
Okay. So we will continue our discussion on the introduction of signals and systems. And we have discussed the signals. We have discussed few example of signals and systems as well. And last class, we were discussing this periodic signal. Okay. And this kind of periodic signals will be discussed in detail later, while we'll be discussing the Fourier series. Okay, to find the frequency content of signals. Okay, so for time being, we'll move to the next topic. We may consider this one. Next, we may consider time shifting, or in general, we can consider the operations on signals. Okay. So first one, we may consider time shifting. So here we are considering that signal is in time domain, but already we have discussed that the signal should depend on an independent variables. It may be time or maybe other dimension like spatial dimension x, y, that kind of thing. Okay, or temperature. But if nothing is set, then we will consider that the independent dimension is nothing but time. That's how I am calling it time shifting. So if my original signal is xt, so xt is the original signal. Now, what is x of t minus, suppose capital T? What is the meaning of this? That we want to understand. Okay. So just look at, so I'll take one example. It will be better. So this is time reference, x-axis, t, this is axis t, this is 0, and suppose this is the signal. So this is suppose -2, and this is suppose +3, and this height is 1. This is your xt. Okay. Now, if you want to convert I want a signal yt, which is nothing but x of t minus 1. Suppose, for example. So you see, so if I consider this independent time variable t, then that time what is your xt, and that time what is your corresponding yt, which is nothing but x of t minus 1. Okay, I'll take few example. Suppose t equal to 0. At t equal to 0, it is nothing but x of 0 at 0. Okay, and from this figure, x of 0 is nothing but 1. It's okay. And what is this? It is y of 0, and that is nothing but x of, this is 0 minus 1, it is minus 1. So at minus 1, whatever its height is there, this value, that value should be y of 0. Okay, so if I consider this is t-axis, so at 0, this is at t equal to 0, its value should be this one. Okay, so this same value I should get. Is it right? Now, if I consider t equal to 1, then it is x of 1. And x of 1, some value you can get this value. Okay. And at y equal to 1, this is nothing but it is x of 0. 1 minus 1 is 0. And x of 0 is already given. That is nothing but 1. Okay. So this value, x of 1 value, you can compute from this figure. So if it is purely straight line, then you can find the value. What is the value? So anyone can tell me if it is a straight line? This is straight line. This is also straight line. So what is the height at t equal to 1 for x of t? Anybody? Am I audible?
Yes, sir,
Yes,
you are
sir.
audible.
Okay. So can you tell me what is the value at t equal to 1 for x of t?
2/3.
2/3?
Yes, sir.
Is it fine? So this value is 2 upon 3. Okay, good. That you can calculate on the basis of this slope. The slope you can compute, then this is the one, then what would be the height, those things you can calculate. And t equal to 2, what is the value?
1/3.
1/3. It's fine.
Yes, sir. Yes, sir.
Okay. And for this one, x of minus 1, what is the value? Can you tell me what is the value of our x of minus 1?
Minus half.
0.5.
Minus. Why minus?
Sorry, sir. Plus 0.5.
Yeah, it is always positive. No, this is in the middle, and this is at minus 2, it is 0. It is a middle value. So it is half, 0.5. Good. So this is 0.5. That means x of minus 1 is 0.5. So this value is 0.5. It's okay. And x of 0 is already given. So this is at 1. So at 1, this value is 1. It's like this. It would be here. Okay. This is at 1. And now, similarly, you can compute some suppose if I go for x equal to 2, sorry, t equal to 2, then x of 2, already you have computed. This is nothing but 1 upon 3. And y of 2, because it is a 2 minus 1, x of, it is 1 only, x of 1, and x of 1 is 2 upon 3. So at 2, it is 2 upon 3. It could be here. Okay. Similarly, for 3, x of 3, you will see it is nothing but 0. And its y of 3 is nothing but x of 2. It is nothing but 1 upon 3. And if you continue, this 4. So x of 4, nothing is there, it is 0. But y of 4 is nothing but x of 3. And x of 3 is already given 0. So it is now becoming 0. So next onward, it will become 0. Okay. Similarly, if you consider negative side, if it is -1, then x of -1, you see the figure, x of -1 is 0.5. The 0.5, and y of -1 is nothing but x of, you see -1 minus 1 is -2. So x of -2, and that value is already given 0. This is 0. So you see this value is x of -1, it is 0. Now if you join all the points, so I'll join with red one. Okay. So this is nothing but y of t, which is x of t minus 1. And just see the difference. So this image, this signal is just shifted right side by, so this is the peak value. That peak value was around, it was at 0 for original signal xt, but this yt, x of t minus 1, its peak value at t equal to 1. Okay. So entire signal is shifted to right side by unit 1. Okay. That's how this kind of thing, it is shifting. So if it is minus, you see it is right shift. If it is plus, it will be left shift. I think it is clear from this figure. Okay. So x of t minus capital T is nothing but right shift by t second. Remember, t I am considering positive. Okay. If t is positive, then it is right shift. But if t is negative, in that case, so x of t plus capital T, that will imply left shift by t second. Is it clear to all of you?
Yes, sir.
Okay, very simple thing.
Sir,
Understand?
could you
Yeah,
please
any question?
repeat the last? Could you please repeat the last part? I lost connection.
Should I repeat it?
The shifting part, right shifting.
Yeah. So you see, just look at this figure. What I am saying, that left hand side I have taken one signal x of t. That is some kind of triangular. This side is linear. This is also a straight line. Okay. Then for every t, I have considered x of t, its original value. And then I'll be mapping with this y of t. And it is given that y of t is nothing but x of t minus 1. So when I'll consider t equal to 0, I'll put t equal to 0 here. So it is x of 0. And x of 0 I can compute from the given signal. And in the given signal, its value is 1. that I can put it here. And then y of t, which is x of t minus 1, I'll put t equal to 0 here. So it is y of 0. This is x of 0 minus 1 is x of minus 1. And x of minus 1 from the figure, I can calculate its value is 0.5. So that I have recorded here. Similarly, for t equal to 1, it is x of 1. And in that case, y of 1 is nothing but x of 0. So you see here, you can notice here, what is this? This y of 0 is corresponding to x of minus 1. Y of 1 is corresponding to x of 0. Y of 2 is corresponding to x of 1. So this y higher value, any t value, such like 3, then x of 2. So whatever signal was there at 2, it is now available at 3 for y, like this. So this point is mapped to this point. Is it right? This 2, t equal to 2, whatever its value was there, x of 2, the same thing we'll get here. This value is x of 2, which is nothing but y of 3. So indeed, what is happening? The entire signal is shifted to right side by unit 1 if it is yt is x of t minus 1. So this 1 indicates that it is shifted by 1 second. That's simple. But if it is positive, then it will be shifted on the left hand side by that unit, capital T second. So I'll be giving you some example, more example. So if it is like this, sorry. Okay, if this is my x of t, this is minus 2, this is minus 1, this is plus 1, and this height is 2, and this is 1. Okay. Now, if I ask you to draw, find y of t, which is nothing but x of t plus 3, can I draw? So can you draw the signal y of t, which is nothing but x of t plus 3? So what is this? It is a time shift. Which side, left side or right side? Anyone?
Left side.
Left side.
Left side.
Left side,
Negative
sir.
sign.
So left side by 3 unit. So this
3
one,
seconds.
this point is shifted by 3 second left side. So this one is subtracted by 3. So 1 minus 3. It will now become minus 2. Okay. So what was the position here? That is mapped to, so it is minus 1. It is minus 2. So that is available here. Okay. So this height 2 that I can draw here. Okay. Similarly, this 0 is shifted to minus 3. And still it is at 2. So this shape, you will have the similar shape. Shape is not changing, only shifting. Then this minus 1 corresponding to minus 4. Minus 2 is corresponding to minus 5. So is minus 5. What is happening? So here it is 1 level. To continue with this 4 after 4. And then there's a slope here. Okay. This is the height 2. This is the height 1. So this signal is y of t, which is nothing but x of t plus 3. Is it fine, everybody?
Yes.
So entire signal is shifted to the left side by 3 seconds, 3 unit. Good. So now you can understand that if it is right side, so if it is minus, then it is right side. If it is plus, it is left side. Now second one, time scaling. Now if signal is given, this is your original signal. Now we want to understand what is the shape for suppose x of 80. What is this? Now something is multiplied with t. For example, x of 2t or x of, it could be t by 3 as well. So what is the shape? Fine. Now you see what I can do. I'll take again one example, then it will be clear. Okay, I'll take the same example. Okay, I'll go for, sorry. So this is the signal. Okay. So this is a signal, same signal. What we're going for, sorry. Now, first I'll go for x equal to 2t. So this should be my y. So can you draw? The time t. Here I need to draw yt, which is nothing but x of 2t. So again, similarly, we can take the values for t. Then we can compute corresponding x of t. And then I'll go for yt, which is given x of 2t. Okay. Now, t equal to 0. At t equal to 0 here, its value is 2. So this value is x of 0 equal to 2. Okay. So what is the value at 0? So this is y of 0, which is nothing but again, I'll put t equal to 0 here. So 2 into 0 is remaining 0. So it is remaining here. So whatever origin, the value was x of 0. So after the scaling, whether it is multiplied or divided, doesn't matter, origin will remain same. It will remain same at 2. Yes. Okay. This is t equal to 0. Now if I go for t equal to 1. Okay. At t equal to 1, it is the x of 1. Again, it will remain 2. So it is height 2, but it is going down straightforward way. It's fine. Now, what is your y of 1? And that is nothing but x of 2. Because 2 into 1 is 2. And x of 2, you see, its value is 0. So at 1, so this is 1, its value is 0. Okay. Now, if I consider t equal to half, then x of half this is also 2. This is at here, middle is half. So within 0 to 1, it is a constant at 2. So you see here, it is a y of half. And that is nothing but x of 1. And x of 1 is given as 2. Okay. So what is the meaning? Meaning is that this 1 point, this x of 1. So if I consider this thing, just look at this 1 is mapped with half. So this 1 should be mapped with someone here. Okay. This will be half. So I can understand, we can understand that this flatness, it will remain flat till half. Okay. Similarly, this minus 1 point should corresponding to minus half. Okay. And this minus 2 corresponding to minus 2 by 2 is minus 1. So I can draw the figure like this. Is it clear a little bit?
Yes, sir.
Yes, sir.
Yes. So what is that? If I multiply by some value which is larger than 1, in that case we will get compression. Compressed, signal is compressed. So earlier width was -3 to 1. This was the width. So total is 3-second gap. And now you see the gap between this and this. It will be 3 by 2 because this side is 1 width, this is half. So 1 plus half is 3 by 2. So it is half. Width is becoming half. It is compressed by 2 times. So whenever signal is, some value is multiplied in with t, and that parameter, the value is more than 1, then it is compression. So in general, we can write we can conclude that x of at is compression if a is greater than 1. Okay. And is expansion if a is within 0 to 1. Like if we consider a signal like this, This is -1, this is -2, this is 0, and this is suppose 3. This is your x of t. Now if I want to compute yt, which is nothing but x of t by 2, then what we'll get? We'll get expansion of signal. Signal is expanded in time axis, okay? So 0 will remain same. So origin will remain same. It will be at 3. But this 2 minus, sorry, this is plus 2. This plus 2 should map to, it's multiplied by this 2. So 2 is the 4. This -1 should be mapped to -1 into 2 is -2. So you see the figure will be like this, and this side, this one. This is your x of t by 2. Is it clear?
Yes, sir.
It's fine. Now there is one point here. I have considered that scaling factor A is always positive, but it could be also negative. Now, what is the meaning of this one? So I'll call it time reverse. Time reversal. Okay. What is that? So from xt, if we compute x of minus t, then what will happen? So in this case, a is nothing but, so it is equivalent to x of t, at, with a equals to -1. That's all. So what is that? So what is happening? So if I take one example like this, I can consider. So this value is -2 or -3. It is -2. This one. Then this side. This is suppose at 5. It's 0. And this is the xt. And its value is suppose 2. Then can I draw yt, which is nothing but x of minus t? What is the shape?
It would flip along the y-axis.
Yes.
Graph around y-axis.
So can you speak loudly, please?
So we will get the reflection of graph about y-axis.
So I am not getting you properly. Anyway,
The graph will
along the
flip
y-axis.
about
It will be like mirror image with respect
yeah,
to
it will be images kind of thing. Exactly. So see, if I consider t equals to 2, suppose. So at y of 2, okay. So this is the 2. So here I should get y of 2, and y of 2 is nothing but, so you see this point. So this is the xt, and this is the yt. Is nothing but x of minus t. What is happening? So if I start with 0, then it is x of 0, and it is y of 0 is nothing but again x of 0. So it implies that in origin there is no change. It's true again here because it's a time scaling. And already I've said that for time scaling, the origin is not modified. At origin, whatever value was there, it would remain same. And it will remain at origin. Magnitude. So origin is mapped to original. Okay. But if I consider it is -2, so it is x of -2. But you see here, y of -2 is nothing but x of simply 2. So y of -2, this side should map to its +2. So whatever height it is here, that should be here. Okay, so 0 origin is mapped to 2. It is fine. And this one is mapped to this. So this is mapped to -2. And this similarly, this -1 should come here. Plus, like 2, if I consider it is x of 2, this is y of 2, is nothing but this x of -2. Okay, so this point will be here. So what's the meaning? And this -3 is going from +3. So you'll get, so it's same shape. Okay, it's nothing compression, not all those things. Only thing is like this. This is your, and this 5 will be mapped to -5 here. So we may consider that this signal is nothing but a mirror image of x of t with respect to y-axis. So right side will become left side and left side will become right side. Is it fine?
Yes, sir.
Okay. And this type of technique is called sometimes folding. Okay. We can fold it with respect to y-axis. Then right side will become left side and left side will become right side. So axis will interchange. Okay. Yes, interchange. So this is folding. We will be calling it at folding instead of time reversal. Basically, time reversal is nothing but folding. Okay. Now, sometimes we can have both time scaling and time shifting together. Okay. So in that case, what you will do? Suppose xt is given. And from that, I want to compute x of 2t minus 3. Okay. So this is the requirement. Now, can I take one example? A simple example we'll try to take. This side is -1 and this side is, suppose at 4. Is it at suppose 5 level? I am taking some values which are not common here. So this is your x of t. So what would be the same? Okay. So who can draw?
Can I?
So can you tell me what is the mapping? Mapping here. So how origin is shifted? So this origin at t equal to 0, x of 0. Now what is the new location at this axis? T axis. Yes?
X equals to 3.
Sir,
T
x
equals
equals
to?
to 3 by 2. T equals to 3 by 2.
T equal to 3 by 2, exactly. So when I will get 0, this, so here what I want to that. So here it is x of 0, I will get it here. Similarly, I want to get this yt. When this one, I will get x of 0. That is the concern. So at what value of t? Okay, so what we'll do, we'll put it 0. So this one, so 2t minus 3, that I can make it 0. So this is nothing but solution is 3 by 2. Okay, so I can understand that at 3 by 2, so there is a mapping between 0 and 3 by 2 here. Earlier it was 0, now it is, so this value is 5. That is fine. Now similarly, this minus 1, how it is mapped? Minus 1. So when I will get minus 1, x of minus 1, for which? So similarly again, so 2t minus 3, when this value will become minus 1, for what t? So this is nothing but 2t equals to, so 3 plus minus 1 is 2, so then t equals to 1. Am I correct? So this minus 1 should be mapped to plus 1, and plus 1 could be here. Is it okay? And what is the 4? How 4 is mapped? 1 minute.
3.5.
I will get, so what value of t? Okay, that we need to compare. Am I audible?
3.5, sir.
Yeah, 3.5. Correct?
ST.
So this 4 is mapped to 3.5. One minute. So this 4 is mapped to 3.5 here, suppose. This is your 3.5, means 7 by 2. So signal is like this. This is at 1. You start from 1 and it will end at 3.5. So width is nothing but 2.5. Earlier width was 5. This width was 5. Now width is simply this to this. This width is nothing but 2.5. It is half of that. So this twice of this one, it's simply, it will say that it is a compression. It's compressed by 2. So width is reduced by 2. That will be sure. And now shifting here, you have to be very careful. This origin is not shifted by 3. Remember, the origin is not exactly shifted by 3. Rather, this origin is shifted by 3 by 2. Is it correct?
Yes, sir.
So there should not be any confusion. So what you can do, we can get the resulting one by taking one operation at a time. So what I can do, so if I start with xt, then if t is replaced by 2t, then what will get? X of 2t. Is it correct? And then if t is replaced by t minus 3 by 2, then what you will get? X of 2 it was there, and t is replaced by t minus 3 by 2. Okay, this one. And this is nothing but x of, we multiply 2t, and it is minus 3. Is it correct? So to obtain x of 2t minus 3, I can have one operation first. T should be replaced by 2t. It is nothing but scaling. So I am going scaling first and then shifting. Fine. So scaling by 2 means compressed by 2. And then that compressed signal is shifted by right side by 3 by 2 unit. Is it okay?
Yes, sir.
So
Yes, sir.
you see the signal. The signal I have considered is -1 probably, and this side is 4. It was like this. Is at 5. This is your xt. Now this x of 2t means t is replaced by 2t. And what is signal? It's a compressed. So this -1 should be at -12, and -4 should be 4 by 2 is 2. It will be like this. Okay, and it will remain at 0. The origin remains. So this point is -12. This point is 2. So it is compressed. So this is your x of 2t. Now this signal, if t is replaced by t minus 3 by 2, so entire signal should be shifted by 3 by 2 unit. Okay, so this origin is here at 3 by 2, and then I can draw the entire figure, this compressed signal here. So around origin, what shape was there, that thing I can draw here. So it is half unit distance. So 3 by 2 minus half, it will become 1. 2 plus 3 by 2 means 3.5. And this height is 5. This is your yt, which is nothing but x of 2t minus 3. Is it clear to everybody?
Yes.
Yes,
Yes,
sir.
sir.
Yes? Any doubt, please? No? Nobody is having a doubt? So these are fundamental operations you should understand very clearly. We'll be using these operations regularly. Okay? I hope we should not repeat it in future. Okay? Now, same thing we can do in reverse way. Means we can take shifting first, then we can also go for scaling. We should get the same result. Okay? Means, so this is one way. The second way, what I can do, I can start with xt, then t should be replaced by t minus 3, then what will get? X of 2t minus 3. That is fine. Sorry, that's so. We will get x of, so t is replaced by t minus 3, so you will get x of t minus 3 all. Fine. Then if t is replaced by 2t, then obviously you will get, so t is replaced by 2t, so here I replace by 2t, and minus 3 is independent of t, so I should get x of 2t minus 3. Is it fine? So end result should be same. Can you try this one?
Sir,
So yeah,
sir, if we consider independent t and we just multiply 2 to t, so in the above example, when we did then shifting, the time we multiplied and
I am not getting you properly. Is it my problem? I don't know.
sir, I
Or it's your network problem. You are not completely audible. Can you repeat please one more time? Can you try?
Sir, I got it. It was my mistake. There is some
You got it.
issue on my side. Yeah, there's some issue on my side.
Okay. Then so you try to understand. So again, I repeat it. Fine. So now it is, this is TBT is replaced by t minus 3. It is nothing but shifting. And this is your scaling. Okay. So shifting, so it is shifted by the 3 unit right side. This implies. And this scaling will imply that resulting signal here, it is scaled down by 2 unit. Okay, means it is compressed by 2 unit. So the signal was like this. So this is minus 1. What I'll get? The entire signal, this origin, is shifted at 3 unit. So here I should get everything. Okay, this point, so if it is 3, this point is mapped to 3 plus 1, it's 2. Sorry, this is plus sign. And this 4 is mapped to 7. All points are added by 3. So minus 1 plus 3 is 2, 0 plus 3 is 3, 4 plus 3 is 7. So entire signal is shifted right side by 3 units. Okay. So your height was 5 to remain 5. So this is your x of t minus 3. Now, if t is replaced by 2t, then what you will get? Fine. So if it is 2t, it is compressed. So all the values is divided by 2. Okay, this 7 is divided by 2 is 7 by 2. So it will come at here. This 2 is divided by 2 is 1. Is 1. 3 is divided by 2. It is 3 by 2. So this is the maximum peak. So you see, this is the same. This is the x of 2t minus 3. I think you have got the same result. This result and this result is exactly same. Okay, is it clear?
Yes, sir.
So any composite, any signal is given where there are shifting operation and scaling operation both. So you can take any one first, but be careful. If you take shifting, then that shifting first, then that shifting is very simple. It will remain same. And then scaling is also same. So this operation is very easy to understand. But if you take is x of t, x of 2t, then be careful about shifting. So shifting is not only 3, it is basically 3 by 2. Okay? Don't make any mistake here. So if you start with scaling, followed by shifting, then in shifting, you have to be very careful because it should be not shifted by that constant unit only. It is basically that by this one. Okay? I hope it is clear. So any question? Am I audible?
Yes.
Yes, sir.
Yes, sir.
Okay.
Yes,
Are
sir.
you enjoying? Or more some mathematical things are coming? That's how it's problematic. Is it okay with all of you?
Yes, sir. Yes.
Yes, sir. Yes.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Very, very nice. Because these are the fundamental things we should understand first. Then we can enjoy signal processing course totally. Okay. So we have done these two operations. One is time scaling and time shifting. Now, third one, addition of signals. If you consider. If you want to add more than one signal, we want to combine the signals, okay? Like suppose x1t given, x2t given, I want to get this x1t plus x2t. And what is the shape? Okay, so can I draw it quickly? So very simple thing is that, suppose if I have one signal like this, so it is -2, it is +2, this is your x1t, height is 1, and x2t is, suppose this one, this is -1, this is a +1, and this is suppose 3, this is your x2t. Now can I add these two together? What would be the resulting signal? I want to get xt, which is nothing but x1t plus x2t. Can you add these two? Anyone?
Yes, sir.
Okay, what could be the shape? Can you discuss? So
Like,
what is the
sir,
value between -2 to -1?
It would remain 1.
It would remain 1. And -1 to 0?
Linearly increasing from
linearly increasing
Good.
from
And what is the maximum height?
4.
1 to
4.
4. It would
It's
increase
added
linearly.
because this x1 is 1. This is the contribution from x1, and x2 will contribute 3. So at origin it will be 1 plus 3 is 4. Nice. So what is visualization? So we can consider that it is -2. It's a +2. So this was the signal. This is basically x1t. On top of this one, I can write x2t. Okay. So x2t. So if I consider this is the base, then above this I can add. No. Simply I can add these two together. So resulting would be is it okay? This maximum height is 4. This height is 1. Okay. And this is 1 minus 1. And this is your +1. Okay. So it is very simple. That is simple person. Similarly, subtraction is also simple. Addition means not only always added, we can also subtract this one. So if we want to subtract, then what we will get? Can you draw? Suppose I want to get xt, which is nothing but x1t minus x2t. Can I get?
Sir, we can flip x2 of t with respect to y equal to
Yes.
0.
Good, good. So if this is x of t, x2 of t, I can consider minus x. So simply minus x2 of t, if I want to consider. So what will happen? This magnitude is reversed. So magnitude is increasing. So at 0 it is +3. Now it has become -3. That's simple. So this is at -1. This is +1. So this is your minus x2 of t. So these and these simply I can add. Now, so again similar way we can do it. So this is your -2 and +2 for x1t. Now I can add this one. So with respect to this one, Now I can place this thing. So this is it from here. So it will be +1 and -3 is -2. Probably here. Okay. Am I correct? So resulting one could be like this. This is your -2. Okay, and this point is -1. This point is -2. Sorry, +1. Is it fine, everybody?
Sir, could you please repeat the subtraction part?
Subtraction part. So every time it is subtracted. No. So if this is alone x1t, I'll get only this one. So -2 to +2 only flat thing at one level. Now this part is subtracted. Now this x2 is active within this one, -1 to 1. And that time some value, these values are subtracted. So within this one, +1, -1 and +1, what is happening? Now these values are subtracted. So at origin 3 is subtracted. So at origin earlier it was 1. So 1 minus 3, it will become -2. So resulting value at origin it should be -2. Okay. So from here it was flat, now it is reduced. So we are going to subtract this curve, this positive increasing curve. So what will get? I'll get a downward curve. So from here it is reducing and it should go up to -2. That is the meaning. Okay. So easy way is that just flip this signal x2 of t with respect to x-axis. So positive will become negative, then simply add. Try to add it. Means over this previous signal, try to add this signal. That's all. So okay, let me take one more example. Then probably it will be clear. So can I draw xt, which is nothing but 2 plus sine 4 phi t. Okay. How can I draw this signal 2 plus sine 4 pi t? So you see it is the addition of two signals. One is 2. So it's a DC only. It is not changing with the time. So that one first I can draw. So this is the level at 2. Okay. Now on this level there is sine wave. So you know the sine wave is fluctuating one. It's a periodic one. And what is the frequency of the sine wave?
2.
2 hertz.
2
Okay.
hertz.
Always mention the unit. It's the 2 hertz. Or you can write the angular frequency is 4 pi radian per second. Okay. So it will start from 0 onward. And what is the amplitude? Amplitude is not given, means 1. So maximum height will be 1. So what I can do, above this reference line, so this will behave as a reference line. And now I can draw the sine wave on this line. So simply a sine wave. like this. Is it fine? So this is your resulting signal, maximum height. What is the maximum height? So 2 plus 1 is 3. And minimum height. So it's 2 minus 1. When sign value is minus 1, then it will be 2 minus 1 means 1. So this signal x of t is confined between plus 3 and plus 1. So x of t always we can write confined between 1 to 3. Am I correct? Is it okay?
Yes, sir.
Yes, sir. Yes, sir.
Now, if I want to add two signal, which is nothing but like this, suppose xt equals to, so 5 sine 2 pi t plus 0.1, okay, sine also I'm considering sine 10 pi t. So can you draw this composite signal? Now here be careful. Now this signal is a summation of these two. Now which signal is dominating one?
Five to sine to pi t. 5
Five
sine to pi t.
Sine 2 pi t.
So 5 sine 2 pi t is the dominating one. So dominating signal means the highest amplitude. So amplitude is important. This is the strength of the signal. This strength is large, means it is the dominating one. And this strength is, amplitude is only 0.1. Okay. Okay. So can you draw? So this 5 sine over t, so I can write this is 5. This is minus 5. Just 1 minute. I'll draw. Is it okay? This is corresponding to 5 sine 2 pi t. Its frequency is 1 hertz. Now, second component is superposed with this one. Now, if it is absent, then xt is nothing but this thing only. So, due to this one, there is little change. Okay, its strength is low, only 0.1, and sine 10 pi t. So, there is certain undulation because of this second term, and its frequency is 5 times larger than this one. Is it fine? Its frequency is 1 hertz. Its frequency is 1 hertz. This frequency is 5 hertz. Okay, so can I have this kind of thing? Can you guess? Some undulation which is fluctuating with respect to this one. Roughly I am drawing. So I may not be upper scale, but this fluctuation is due to this 0.1 sine 10 pi t. So red one is x of t. Is it okay? Am I clear?
Yes, sir.
So I will give you more example in the next class. So this is more important thing to understand, because signal processing codes is nothing but the summation of signals and those signals will be processed by systems. So you need to understand, and this kind of signals you will encounter frequently. Okay, so we'll stop here today. We'll continue our discussion from here. I think I have to take one more lectures on signals, then we'll move to systems. Okay, if you have any question, you can ask me.
Sir, are you planning to share this paint written notes, or would you not share it?
Yeah, I'll share this recorded one, or also paint also I can share with you. But thing is that if once one chapter is completed, then only I'll be sharing with you. Okay, so I want that everybody will be present here.
Okay, sir. So it would be on Moodle or Google Classroom?
I'll share you the link. So I'll keep it to my drive, and probably I can share with you. You can download it. Okay, I'll give you the link, so it will be
Okay, sir.
visible to you. Right? Okay, I'll inform all of you. But please attend my lectures regularly. But this one, this paint one, that I can share with you right now. But who are not attending the lectures, they will not be able to understand anything from my this paint file, because I'm not writing everything. No. Okay. So we'll continue in the next class. Fine.